As a philosopher, I bet you spend a lot of time thinking about those fundamental concepts that just really make you wonder. And I think few are as tricky as the whole if-then thing. Conditionals, right. They've been puzzling logicians forever.
Oh, absolutely. I mean, for something we use so naturally in everyday language and reasoning, the conditional has really resisted any simple explanation and logic. It's pretty amazing, actually, how the effort to understand it goes all the way back to ancient times, and we're still working on it today. It just shows how deep the philosophical issues are.
And that's exactly what we're diving into today, the logic of conditionals. We're going to be using that awesome entry from the Stanford Encyclopedia of Philosophy as our guide, kind of like a map through all the different theories and debates. And the goal is to give you a really clear understanding of how philosophers and logicians have tried to make sense of these if-then statements, which, surprisingly, is an area where there's still so much debate.
Yeah, it's a field with a lot of twists and turns, that's for sure. Even a simple conditional can turn out to be way more complex than you'd think when you look at it through the lens of logic. And what we're going to do is focus on the core philosophical ideas, not getting bogged down in all the technical details.
Okay, so let's jump right into the deep end. We've got to start with this. What exactly is the fundamental problem with if? You mentioned that this debate has been going on for a long time.
Oh, it goes way back.
Yeah.
The SFP entry mentions how even the early logicians, like Philo of Megara, were already trying to define a true conditional. And he had this idea that if A, then B is true in every case except when A is true and B is false. Does that ring a bell?
It does. That's basically the foundation of what we call material implication in propositional logic today. The kind of logic that Frege, Russell, and Whitehead worked on. And we can sum it up neatly in that truth table. True implies true is true, true implies false is false, false implies true is true, and false implies false is true as well. It's so simple and elegant, especially for doing mathematical proofs.
It is elegant, and it's incredibly useful in those formal systems. But, as this FP entry points out pretty quickly, this neat framework runs into some big problems when we try to apply it to how we actually use conditionals in everyday language.
Yeah.
That's where the philosophical puzzles really start to come up.
Right? Like, think about that observation from McCall that they highlight in the entry. He noticed that according to material implication, if you take any two statements, at least one of these has to be true, not A or B, or not B or A. But if we think of those as equivalent to if A then B and if B then A, then it's like saying that for any two random statements, it could be anything like John is a physician and John has red hair. One of these has to be true. Either if John is a physician, then he has red hair, or if John has red hair, then he's a physician. And that just doesn't feel right intuitively, does it?
Not at all. That example gets to the heart of the problem. Material implication often misses that sense of relevance, that there should be some kind of necessary connection between what comes after the if and what comes after the then. And then, of course, there are the famous paradoxes of material implication.
Those are always a bit mind-bending. The fact that if A then B is logically true, if not A is true. So I could say, if the moon is made of cheese, then Paris is the capital of France. And that would be logically true simply because the moon isn't actually made of cheese. And the same thing goes if B is true. So since Paris is the capital of France, then the statement, if the moon is made of cheese, then Paris is the capital of France is true, regardless of what the moon is made of. It's as if the actual content of the statements becomes irrelevant.
You got it. The truth or falsity of the individual parts dictates the truth of the whole conditional without any real link between them. And the ACP entry also mentions the issue of negation. If we take the negation of if A then B to be A and not B, which is how it works with material implication, that doesn't always feel right for how we use conditionals in language. For instance, consider the statement, if God exists, then all prayers are answered. Someone could disagree with that statement without actually believing that God exists, and some prayers aren't answered. You see what I mean?
Yeah, it's like the negation is targeting the connection itself, not just the fact that the first part is true and the second part is false. And then, of course, there's the whole tricky world of subjunctive conditionals and counterfactuals, those if things had been different statements. Quine pointed out that with material implication, any counterfactual with a false antecedent, the if part automatically becomes true, which is often really unhelpful. Like, if pigs had wings, they could fly, would be true just because pigs don't have wings. It just doesn't capture what we're trying to do with counterfactual reasoning at all.
Right. All these issues with material implication point to a major motivation for developing alternative logics of conditionals, to try to find a way to represent that relationship between the antecedent and the consequent in a way that's more than just whether they both happen to be true or false at the same time, to get at that stronger, more necessary connection.
And that leads us to the realm of modal logic and the idea of strict conditionals. What's the core idea behind this shift?
Well, it's all about capturing that sense of a stronger, more necessary connection, as you said. Modal logic, as you know, brings in these concepts of necessity and possibility. So C.I. Lewis came up with the strict conditional as a way of saying that the material implication between the antecedent and the consequent isn't just true, but it's necessarily true.
So we're not just looking at not A or B being true in our actual world, but we're considering whether it's true across a bunch of other possible worlds.
That's it. In modal semantics, often using those Kripke frames, you have this set of possible worlds and a way of relating them, an accessibility relation that tells you which worlds are relevant or accessible from a given world. A strict conditional, usually written as A, is true in a world if in all the accessible worlds where A is true, B is true as well.
I see. And by bringing in this idea of possible worlds, it seems like we could avoid some of the paradoxes of material implication. Like, a world where the moon is made of cheese might not be considered accessible from our world, so that weird conditional about Elvis being alive wouldn't automatically become true.
Exactly. The strict conditional does get around those paradoxes, and it keeps some of the important logical rules we like, such as modus ponens. If it's necessarily true that if A then B and A is true, then B must also be true, but the SCF entry points out that the strict conditional also retains other principles like monotonicity, transitivity, and contraposition, which started to face their own philosophical problems when applied to both regular and counterfactual conditionals in natural language.
Yeah, those counterexamples are really interesting to think about, like the one about the election where Brown and Smith are running. It challenges transitivity. If Brown wins, then Smith retires. And if Smith dies, then Brown wins. But it doesn't follow that if Smith dies, then Smith retires. That example really shows how this principle can break down in our everyday reasoning about conditionals. And there's that other one about Hoover being a communist and a traitor, which has a similar kind of problem. These examples from thinkers like Adams, Stalnaker, and Lewis made people really question these principles.
Definitely. They sparked a lot of debate. Some researchers started exploring probabilistic approaches, while others tried to weaken the strict conditional. But recently, there's been a renewed interest in strict conditionals, but with a twist. The focus is now on how the accessibility relation can change depending on the context. The idea is that what counts as a relevant possible world isn't fixed, but depends on the specific situation. So, a strict conditional could still make sense in a particular context where the possibilities are narrowed down appropriately.
So the strict conditional isn't necessarily wrong, but we have to be careful about how we're using it and how we're understanding what those accessible worlds are.
That's a good way to put it. Philosophers like Daniels and Freeman, von Fintel, Gillies, and Starr are all working on how these context-dependent accessibility relations can give us a more nuanced understanding of how conditionals work in language.
Okay, so we've gone from a single standard of necessity in those strict conditionals to the idea that this standard can actually change depending on the antecedent, what comes after the if. And this brings us to variably strict conditionals. Sounds like this adds even more flexibility to our thinking about conditionals.
It does. The key idea here is that when we evaluate a conditional like if A then B, the set of possible worlds we're considering might change depending on what A is specifically. And the SAP entry lays out three main ways that this idea has been formalized.
Let's break those down. The first one is relative modalities. What's the core concept here?
So with relative modalities, which were really developed by logicians like Chellas and Sagerberg, the idea is that the conditional A-B isn't a material or strict implication, but a kind of modality that depends on A for its meaning. Instead of just one accessibility relation, you have a three-place relation, often written as R sub U sub, where U is the set of worlds where A is true. So R sub U sub holds if world V is accessible from world W, but relative to that proposition U. The truth condition then becomes AB is true at W if B is true in all worlds V that are accessible from W, but only considering those worlds where A is true.
So the possibilities we consider relevant are filtered or selected by the antecedents. It's not a fixed set of possibilities.
Exactly. And the second approach uses selection functions, which Stalnaker and Newt really pushed forward. In this approach, you have a function, FWU, that takes a world W and a proposition U, the set of A worlds, and picks out a subset of worlds from U that are closest or most similar to W. So A, B is true at W if all the worlds picked out by this function are also worlds where B is true.
This focus on the closest or most similar A worlds seems really important for understanding counterfactuals, right? Because when we imagine a what-if scenario, we're usually trying to hold everything else as constant as possible, except for the thing that's different in the if part.
You got it. The third approach uses similarity orderings, which is most closely associated with David Lewis and Burgess. They bring in this three-place relation, written as sub-sub, where U sub-sub V means that world U is more similar to world W than world V is. Then AB is true at W if all the A worlds that are minimally different from W are also B worlds, meaning there's no other A world that's more similar to W.
And the SEP entry mentions this limit assumption when talking about similarity orderings. What's the importance of that assumption?
So the limit assumption basically says that for any world W and any antecedent A, there's always going to be at least one closest A world. Lewis himself had some worries about this assumption, especially for certain counterfactuals. For example, if you say, if Fred was taller than 2 meters, there might not be a single world where that's true that's closest to ours, but instead a whole bunch of worlds where Fred is taller and taller, getting closer and closer to 2 meters, but never actually reaching a closest world. While you can tweak ordering semantics to deal with cases where the limit assumption doesn't hold, it makes things a bit more complicated.
It's so interesting how these three approaches, relative modalities, selection functions, and similarity orderings, are all trying to deal with the fact that conditionals are sensitive to context and that the antecedent plays a key role in determining what's relevant. And as the SCP entry explains, these frameworks can explain why principles like transitivity might not always hold.
That's right. Because we're allowing the set of relevant worlds to shift based on the antecedent, you can imagine situations where A implies B is true within the set of worlds relevant to A, and B implies C is true within the set of worlds relevant to B, but A implies C isn't true within the set of worlds relevant to A. And you get similar puzzles for monotonicity and contraposition when you use these semantics.
And the SCP entry also talks about how these frameworks are related to each other. Like there's a close connection between selection functions and relative modalities, which makes sense. And the link between selection functions and ordering models has to do with thinking about similarity in terms of preferences, which I think opens up some interesting philosophical questions.
Yeah, if you think about similarity as a kind of revealed preference, it creates a really interesting link between these formal semantics and theories of rational choice and belief.
Mhm.
However, those selection function models are usually considered to be more general and adaptable than the ordering models.
And then we have the whole discussion of frame correspondence properties,
Yeah.
which is about how certain constraints on these possible worlds, frameworks like on the accessibility relation, the selection function, or the similarity ordering, can ensure that certain logical axioms for conditionals will hold, like identity AA or conditional excluded middle. Maybe. It's really about understanding how our intuitions about the semantics connect to those logical principles.
It is. Researchers have done a lot of work mapping out these correspondences, which gives us a deeper understanding of how different choices we make at the semantic level lead to different logical properties for conditionals.
Okay, so we've explored the world of possible worlds. Now let's switch gears a bit and look at a different approach, the axiomatic approach and the salient logics of conditionals. How is the understanding of conditionals different in this approach?
Well, the axiomatic approach, which goes back to the work of Frege and Hilbert, takes a different route. Instead of starting with an interpretation based on possible worlds, it tries to define conditional logic by giving a set of basic axioms, things that are logically true about conditionals and rules of inference, that let us derive new truths from those axioms.
And the SCP entry has this whole list of axioms with abbreviations like LT, ID, AND, OR, CCUT, CMON, REC, SM, CS, ARMON, CEM. It's a lot to take in.
It is, but each of those abbreviations stands for a specific principle about how conditionals work, and most of them seem pretty intuitive. Like, ID is for identity, the idea that if A, then A is always true. And D is about the idea that if A implies B and A implies C, then A implies both B and C together. And OR says that if A implies C and B implies C, then either A or B implies C. Each axiom is trying to capture some basic part of how we reason with conditionals.
And then there are all these different systems of conditional logic, things like CK, B, SS, NP, V, VW, VC, C2, each defined by which axioms and inference rules they include. What's the significance of having all these different systems?
These systems reflect different choices about which principles of conditional reasoning we think are the most fundamental and always true. CK, for instance, is often seen as the most basic conditional logic, similar to the modal logic K. It uses rules like left logical equivalence, LLE, right weakening, RW, and rule of conditional K, RCK, and basic axioms like logical truth, LT, and identity, ID.
So by adding or taking away axioms, we get different logics, and each one allows for different inferences. Like System B, which Burgess proposed, includes identity, OR, and cautious monotonicity, CMON. It's interesting that the entry points out a connection between a part of System B specifically, conditionals that aren't nested, and System P, which is a non-monotonic logic. That seems like an important link.
It is. System P, which Krauss, Lehman, and Magidor developed, is a way of reasoning with defaults. Statements like, if A, then normally C. The fact that part of a standard conditional logic lines up with a logic for defaults suggests a deep connection between how we understand conditionals and how we reason with information that might be incomplete or could change. And there's more. System P is also sounding complete when you use Adams's probabilistic semantics for conditionals, which we'll talk about later, and it can even be characterized using three-valued logic.
It's interesting that the entry emphasizes that a lot of those seemingly basic principles, like monotonicity, transitivity, and contraposition, aren't generally valid in these axiomatic systems. They might seem intuitive, but when you look at them closely, they don't always hold up, which I guess shows how conditional reasoning is different from classical logic.
Exactly. The fact that many conditional logics reject these principles shows a commitment to capturing the subtleties and context dependence of if-then statements. And those other systems you mentioned, V, SS, VC, VW, C2, are further refinements, adding more axioms to CK or B to capture different intuitions. For instance, C2 is Stallnaker's logic, and it includes that controversial principle, conditional excluded middle, CEM.
The entry also mentions Del Grande's system in P, which is different from B because it uses rational monotonicity, REO monon, instead of cautious monotonicity. It just goes to show that there are these subtle but important differences between these principles of non-monotonic reasoning.
Right, and the debates about whether axioms like conditional excluded middle, cautious monotonicity, and rational monotonicity are actually valid highlight the fact that there isn't one correct set of fundamental principles for conditional logic. There are all these different systems, each reflecting different priorities and intuitions about how conditionals work.
This whole connection to default reasoning seems really important. Let's take a little deeper into that, looking at conditionals as defaults and this framework of non-monotonic logic and preferential models. What's the fundamental shift in thinking here?
The key difference is that we're moving away from thinking about conditionals as expressing something that's always true in every relevant situation, and towards understanding them as expressing what's normally or typically the case, what we might call defeasible inferences. Krauss, Lehman, and Magidor, or KLM, really pioneered this approach. They focused on what makes a system of default inferences, which they represented as conditionals like if A, then normally C, rational.
So the focus is no longer on truth in different possible worlds, but on whether we're justified in drawing a conclusion based on what we know, even if that conclusion might turn out to be wrong if we learn more.
Exactly. KLM use models with states, which represent different bits of information or scenarios, and worlds, which represent complete assignments of truth values to propositions. In their preferential models, they introduce a preference relation over these states, reflecting a sense of what's considered more normal or typical.
The entry mentions cumulative models and this smoothness condition. What do those mean?
Cumulative models provide a more general framework for non-monotonic reasoning. The smoothness condition ensures that when you look at states where a condition A holds, there are going to be some most preferred or minimal states among them. It's similar to that limit assumption we discussed earlier. This lets us define a non-monotonic entailment relation. A normally implies B is true if B is true in all those minimal states where A is true.
So preferential models are a special type of cumulative model, but with a more organized way of ranking those states.
That's right. In preferential models, the preference relation over states is a strict partial order. Lehman and Magidor took this a step further with ranked models, where this order is modular, meaning you can basically arrange the states in a hierarchy of normality.
The SFP entry then lists those core rules of System P identity, left logical equivalence, right weakening, cautious monotonicity, and OR. They emphasize that these rules should be seen as basic requirements for any system of default reasoning to be considered rational. What do these rules tell us about how we reason with defaults?
Each of these rules captures a way of making default inferences that seems rational. Like cautious monotonicity says that you can add a conclusion B to the antecedent of a default. If A, then normally C, to get if A and B, then normally C, as long as you've already inferred if A, then normally B. It's like saying that if you add something typical to a typical situation, it shouldn't change other typical conclusions. And the fact that system P with these rules corresponds to part of a standard conditional logic, system B, strengthens that link between these two areas of logic.
Then there's system R, which is for rational reasoning and is made by adding rational monotonicity. And the entry points out that this rule has a bit of an unusual form.
Yeah, rational monotonicity lets you infer if A and B, then normally C, from if A, then normally C, if you don't have the inference, if A, then normally not B. This rule is a bit more sophisticated in terms of non-monotonicity. It lets you make default inferences unless you have some reason to think otherwise. And the fact that system R is complete with respect to those ranked models further connects this way of reasoning to a hierarchical view of normality.
It's really interesting how these non-monotonic logics try to formalize that everyday reasoning we do, which is often based on assumptions and expectations that we revise as we get new information.
Absolutely. They're really helpful for understanding how much of our reasoning is diffusible and how we deal with a world where we never have complete information.
Now, the SOP entry dives into a few specific principles that seem pretty basic, but they actually cause problems for a lot of conditional logics. Or to if, import, export, and simplification of disjunctive antecedents. They work fine for material implication, but things get more complicated in those other systems. Let's start with or to if, OI. What's the issue there?
Or to if is the principle that A or B implies, if not A, then B. At first glance, it seems pretty intuitive. It's like saying that if one of two things has to be true and the first one isn't, then the second one must be. But, as C.I. Lewis showed, accepting this principle, along with some others, can lead to paradoxes similar to the ones we saw with material implication.
Stolnaker, as the entry mentions, thought that while OI might make sense in some conversational contexts, it's not a universal logical truth about conditionals. That distinction between what's pragmatically useful and what's logically valid comes up a lot in philosophy of language.
It does. Next up is import-export, i.e., that's the idea that if A then if B then C is equivalent to if A and B then C. This one has also been a source of debate in logic.
The entry highlights Gibbard's work, which showed that if you accept modus ponens, i.e. left logical equivalence, and that the conditional is logically equivalent to the material conditional, then the strict and material conditionals become the same thing. So i.e. has some pretty strong and maybe not so good consequences.
Right, and McGee came up with this example about an election, which really challenged the idea that IE is always true, especially when you consider it together with modus ponens. He imagined a situation where you might accept if a Republican wins, then if Reagan doesn't win, Anderson will win. But you wouldn't accept if a Republican wins and Reagan doesn't win, then Anderson will win. Because in the second case, Carter might be more likely to win. It raises some really interesting questions about how nested conditionals work and how conjunctions in the antecedent affect things.
And as the entry explains, Mandelkern argued against IE based on context, suggesting that whether it's acceptable might depend on what kind of conditional is embedded. Adams also had concerns based on how certain conditional forms aren't equivalent. And Kaufman pointed out that assumptions about causality might play a role in whether IE is valid. So it seems like while IE might seem like a basic equivalence, there are some serious problems with it, and it's not clear whether it's always true.
Yeah, it's a lot more complicated than it looks at first. And finally, we've got simplification of disjunctive antecedents, SDA, which says that if A or B implies C, then both A implies C and B implies C should be true. This seems pretty plausible, as Chellis and Fine noted.
But as the entry explains, Ellis, Jackson, and Barketter showed that if you accept SDA and left logical equivalence, you end up with monotonicity, which a lot of conditional logics try to avoid.
And because of that, some philosophers have thought about changing or even getting rid of LLE altogether so they can keep SDA without accepting monotonicity. Santorio's work on alternative propositions in the antecedent is one example of that. But even with these changes, there's still debate about whether SDA is always valid. Lassiter came up with this example about betting, which casts doubt on it. The point is that sometimes our intuitions about how conditionals should work can conflict, and we have to make choices about which principles we want to hold on to.
It sounds like with conditionals, you often can't have your cake and eat it, too. If you want to accept one principle that seems intuitive, you might have to reject another one. It shows how interconnected everything is in these formal systems.
It does, and that's an important thing for anyone working on the logic of conditionals to keep in mind. There aren't any simple solutions, and the search for a truly satisfying account is still going on.
Now let's look at a completely different approach. Conditionals build on beliefs, which falls under the category of belief revision approaches. Here, the focus shifts from truth and possible worlds to how our beliefs change when we consider hypothetical situations. What's the motivation for this kind of approach?
The main idea is to explain conditionals in a way that's about our subjective states of belief and acceptance rather than objective truth conditions. People like Gardenfors, Harper, and Levi have been really important in developing these ideas. They usually start with the idea of a belief set, a set of propositions that an agent believes, and this set is logically closed.
So the key to evaluating a conditional like if A then B becomes, imagine we add A to our current beliefs and then see if B follows from those new beliefs.
Right, that's the basic Ramsey test, RT. Then Gardenfors proposed a stronger version, Gardenfors-Ramsey test, GRT, which says that a conditional A-B is accepted, meaning it's part of our beliefs if and only if B is accepted when we add A to our initial beliefs. So from this perspective, conditionals themselves become things we can believe or not believe, and they're subject to the rules of belief revision.
The entry then gets into those AGM postulates for rational belief revision. Those are 8 principles that try to capture how a rational agent should update their beliefs when they get new information. Some of them seem really essential, like success, meaning that after you revise your beliefs with A, you should believe A, and consistency, meaning that revising with something consistent shouldn't lead to inconsistent beliefs.
They're trying to lay out some ground rules for rational belief change, ensuring we make minimal changes while staying rational. For instance, vacuity says that if what you already believe is consistent with the new information A, then revising with A just means adding A and its consequences to your beliefs without getting rid of anything you already believe that's compatible with A. Rational monotonicity, or sometimes called sub-expansion, deals with how you revise beliefs when you learn a conjunction.
One of the most interesting things about this whole approach is Gardenfors' triviality theorem. What's the challenge that this theorem brings up?
Gardenfors showed that there's a fundamental conflict between those seemingly reasonable AGM postulates for belief revision, especially the ones about vacuity and consistency, and his Ramsey test, GRT, for conditionals. The theorem proves that if you try to satisfy both sets of principles, you end up with a really limited model of belief revision, a trivial model that can't even handle basic cases where you have beliefs about 3 propositions that are all inconsistent with each other.
So that's a pretty big obstacle for this whole belief revision approach to conditionals. And the entry talks about different reactions to this triviality result.
Yeah, some philosophers, like Levi, said that conditionals aren't really things you can believe or disbelieve and rejected GRT. Others tried to modify or restrict the Ramsey test in different ways. And another approach was to look at different models of belief change, like belief updates, which were inspired by Lewis's imaging approach. These update models sometimes violate some of the AGM postulates, but they satisfy things like monotonicity.
So the debate is really about which set of principles is more important, the rules of belief revision or the connection between conditionals and beliefs given by the Ramsey test. Rott defended GRT and argued for preserving right-nested conditionals, which adds another layer of complexity to the whole discussion.
It does. Gardenfors' theorem was a major turning point. It made philosophers rethink the connection between how we revise our beliefs and how we understand conditionals. And the fact that there's still no universally accepted solution shows how deep and challenging these issues are.
Let's switch gears again and talk about something that seems really central to conditionals, even though it's hard to define. The importance of connection and the related ideas of relevance and difference-making. It seems like purely truth-functional approaches miss the fact that the antecedent and the consequent should be connected in some way.
You're right. Ever since those early criticisms of material implication, people have argued that any good account of conditionals needs to include this idea of relevance between the parts. But relevance itself is really hard to pin down.
The entry talks about the difference between relevant logics, which focus on topical connections, and the idea of the antecedent actually affecting whether the consequent is true, how likely it is, or whether we should assert it. Let's focus on that second idea, difference-making.
Duvin had this evidential support thesis, EST, which is one way to formalize that idea. He argued that a conditional AC is only assertable if the conditional probability of C given A is high enough, and if the probability of C given A is higher than the probability of C on its own. So A actually increases the probability of C. His example with the coin toss and Chelsea winning illustrates this well. Just having a high conditional probability isn't enough. There has to be this sense of positive relevance.
And the entry says that the logic you get from Duvin's approach is pretty weak. It seems like trying to capture relevance might mean giving up some of those standard logical principles.
That's a common trade-off when you bring relevance into the picture. Krupi and Iacona had a different approach. They used a modified version of the RIPS measure of confirmation to capture uncertainty. Interestingly, their logic is stronger, validating more principles, and it even has some connexive features. They also came up with a possible world semantics for their system.
Rott also had a difference-making conditional within his belief revision framework. His rule for accepting a C that you believe C after revising your beliefs with A, but not after revising them with not A, seems to perfectly capture that idea that A should change whether you believe C.
Exactly. And based on this difference-making idea, Rott rejects conjunctive sufficiency. The logic he ends up with is a bit unusual. It doesn't validate monotonicity, cut, or contraposition, but it does validate and some connexive-like conditions. It shows how prioritizing relevance can lead to non-standard logic.
And it's interesting that Rott's proposal relates to that difference measure
Mhm.
from research on causality in psychology. The finding that Adams' thesis might only be acceptable when it is positive suggests that there's a deep connection between how we understand conditionals logically and psychologically and this idea of difference making.
It does. And the fact that measures like phi, which Roy and Schultz propose, that normalize for how likely things are, seem to predict whether people accept conditionals even better, shows how important these relevance considerations are. It's definitely an area where logic and psychology are coming together.
Finally, let's look at conditionals in broader context, particularly how they interact with modals and speech acts. This takes us beyond just the logic of if and into how it works in more complex language.
Yes, and it shows how conditionals are connected to other fundamental parts of language. The relationship between conditionals and modalities like necessity and possibility has been recognized for a long time. Possible world semantics might suggest that you can define one in terms of the other, but when you look at how language actually works, like the fact that modal operators can switch places with the antecedent of a conditional, it points to a more complex relationship.
Kratzer came up with this restrictor view, where the idea is that if clauses restrict the scope of modal operators. So the statement like, if it rains, then it must be the